titles. Okay, in here, in our operation research, we have totally 18 units. The first 6 units, are comes under the completely introduction of operation research is first unit, and from second unit to up to sixth unit, all these are the LPP problems, that is linear programming problems. When the problem is under the linear programming structure, and if it is linear programming problem, then what about the methods for solving the linear programming problem? That problems we covered up to 6 units, that is 6 chapters in our syllabus. That is first, we have totally around 6 methods. First method is graphical method, that is comes under the unit 2. Next, simplex method, and next, bigger method. Next, two-phase simplex method. Next, degeneracy in simplex method. Actually, this is not a method. This is when the repetition is occurred in minimum ratios. Already you studied about these topics. Just I will recall once again that all chapters wise. So degeneracy in simplex method. That is the method whenever the minimum ratios are repeated. Then how we are going to resolve that situation? That is known as degeneracy in simplex, and resolve it, and how we are going to find the solution. That topics we'll discuss in degeneracy in simplex method. Next one, we have primal and dual problems. So they will give the one linear programming problem, LPP. For that LPP problem, in what way we are going to convert the LP to problem can be converted into primal, to convert it into dual problem. Okay, these two are the subtopics in this primal and dual topics. Okay, and once the problem can be shifted to primal to dual, then again we have to find the general solutions by using simplex method for primal problem as well as for dual problem. In both cases, it shows the objective function value must be same. Okay, that problems also you might have covered in our online mode, offline classes. Next topic comes under the is transportation problems. Unit number 7, transportation problems. In that transportation problems, we have 3 methods for obtaining the initial basic solution. Okay, that is northwest corner method. Okay, and matrix minimum method. It is also known as least cost method. Matrix minimum method and least cost method. And next, we have Vogel's approximation method. Vogel's approximation means it is also one of the method for obtaining the initial basic feasible solution for the given transportation problem. Okay, these 3 are the northwest corner method, matrix minimum method, Vogel's approximation method. These 3 methods will give the what about the initial solution for the given transportation problem. Once the initial basic feasible solution IBFS is obtained, then we have to move the optimality test. Okay, optimality test. How we are going to find the optimality condition? There we have one formula, Dij equal to. Okay, what about Dij formula? Dij equal to Cij minus Ui plus Vj, where Dij is the cell value for non-allocation boxes, and Cij is the cost of corresponding ith row and jth column value, and Ui is the corresponding ith value, and Vj is the corresponding jth value. And with the help of these optimality, if all Dijs are greater than or equal to 0, yes, all Dijs, so we have to calculate individually by using this Dij equal to Cij minus Ui plus Vj. If all Dijs are greater than or equal to 0, then it shows that, as listen carefully, then it shows that as there is an optimum solution is obtained for given transportation problem. So if any one of the Dij is negative, then it shows that whatever the IBFS we got by using that previous 3 methods, that solution is not an optimal solution. Go for the next step, that is by using either MODI method, that is modified distributive method or stepping stone method. So we have two methods. These two methods shows that the optimal, the initial basic feasible solution, whether it is right or not, it can be tested at optimality condition. If all DIJs are greater than or equal to zeros, then stop there only. It shows whatever the IBFS we got, that is the final answer. That is the optimal solution. If at least one of the DIJ is greater than less than zero, means it is a negative quantity, then it shows that whatever the initial basic feasible solution we got, that is not an optimal solution. Then we have to move the next step, that is either MODI method or stepping stone method. These two methods shows that we have to obtain the perfect solution. Means we have to convert all DIJs from negatives to positives. Okay, so apply the MODI method or stepping stone method for that optimality condition. Next step, again go for the DIJ conditions. Once applying these MODI method, then we have to apply the once again optimality test. Again, we have to check out the DIJ conditions. Once the MODI method or stepping stone method is applied, then maximum situation DIJ shows strictly positive values. Okay, if again after applying these MODI or stepping stone method, DIJ shows negative quantities, then go for the one more time MODI method or stepping stone method. Like that, we have to apply these MODI method, that is modified distributive method or stepping stone method, till all DIJs must be greater than or equal to 0. Once all DIJs are greater than or equal to 0, then stop there only. It shows that whatever the solution we got, that is the optimal solution. Or simply you can say the given transportation problem got an optimal solution, and write down its corresponding product of the total minimum transportation cost will be the product of cost with cell value. Cost with cell value, that is the final solution. So these are the topics which we covered in offline mode. Okay, now coming to the next chapter, assignment model problems. Now I'm going to discuss today assignment model problems. Okay, so up to this I discussed whatever the topics you finished in your offline mode. Okay, around 7 chapters, and then I will going to start 8th chapter, that is assignment model problems. Okay, assignment model problem is here. First, I will give the introduction of this. Assignment model problem indicates it is a special case of transportation model problem. Assignment model problem is a special case of transportation model problem, and where in transportation model problem, there we have taken availabilities, that is supply and demand. By row wise we are taken supplies, by column wise we have taken demands. Okay, row 1 supply, row 2 supply, row 3 supply, like that, and column 1 demand, column 2 demand, column 3 demand, like that. But whereas in this assignment model problem, we are not going to take any supplies or demands. Just we are considering the matrix, that is cost matrix only. With the help of these cost matrix only, we have to assign the right person to right job. It means the main application of assignment model problem is, please listen carefully, the main application of the assignment model problem is we have to assign right person to right job so that we can finish the entire task within short period of time. Okay, so it means I will give the one example here. Suppose I'm organizing one institution, let us assume. Okay, now I'm going to conduct interview for 3 different posts. Let us suppose I'm conducting the interviews for in a school level for a mathematics subject, for science subject, and biological subject. Let us assume, and I'm calling 3 persons for interview. So each person will get the job, because 3 jobs, 3 persons we have. Definitely each person will get the job. But my aim is I have to assign the right person to right job so that I can finish the entire task within short period of time. That means suppose 3 persons are came. That 3 persons XYZ, let us suppose 3 persons are capable to teach school subjects, mathematics, physical science, and biological science. But I want to find out which person is the right person to teach maths in thoroughly, and in the less period of time, he can finish the total syllabus. Like that, I want to select the right person among the three. And suppose if I choose some person one to mathematics, person two to some physical science, and person three to some biological science. Let us suppose. So like that, we have to assign the right person to right job, so that we have to finish that entire job with short period of time. Suppose instead of the perfect person in mathematics subject, instead of that person, if I choose another person, even though that person also capable to teach that subject, but he will take maximum time. That is, if the exact the person who thorough in a mathematics subject, if I assign that person, the total syllabus will be finished. Let us suppose either 2 to 3 months. Assume if I choose instead of that expert of mathematics person, if I choose another person, he is also capable to teach math subject, but he will finish that entire subject within 4 to 5 months. So unnecessarily, I am paying the extra salary to that person around 1 or 2 months extra. So that type of situation we have to reduce it with the help of this assignment model technique. So I want to choose a right person to right job, so that I can assign the entire jobs to all persons, and I can finish total syllabus or total task, whatever it may be, within short period of time. That is my motto, or that is my intention. Okay. In that way, these assignment model problem topics is discussed here. Okay. So just I will explain once again. We have to assign right person to right job, so that we have to finish the entire task within short period of time. Okay. So let's suppose there are m jobs, m persons are there. So we have to assign right person to right job, so that we can assign all jobs to each and every one person to one job, so that we can finish the entire task. These kind of problems are known as assignment model problems. And how we are going to solve the problems? Suppose if it is 3%, 3 jobs are there, by visualizing, by saying we can obtain the so and so person will do the job within which short period of time, we can assign like that. But if it is n persons, n jobs are there, so it is very difficult to visualize, or by seeing we can't assign right person to so and so job. In that situation, we have one uh, method for solving the assignment model problem, that is Hungarian assignment method. This is the one of the technique, or one of the most important methods. Ramaya Ramabhadraya Ramachandra. So in this, we one method for solving the assignment model problem, that is Hungarian assignment method. Okay. By using this method, we can assign n person to n jobs. Okay. Maximum number of person. If it is n is very large, even though we can, with the help of this method, we can assign right person to right job. Okay. Before going to start that Hungarian assignment method, let me discuss some basic terminology in this assignment model problem. Suppose a problem is set, assignment problems. 1 minute. Right. So in this year, suppose I have 5 persons, 5 jobs. Okay. With the help of this assignment technique, we can assign the right person to right job. Okay. So whenever we have equal number of persons, the number of persons is equal to the number of jobs. Suppose in a particular problem, we have the number of persons is equal to number of jobs. Then that kind of problem is known as balanced assignment problem. Okay, I will repeat once again here. If there are 5 jobs, 5 persons, then each person will get one job. That kind of problem is known as balanced assignment problem. If it is the number of person does not equal to number of jobs, then that kind of problem is known as unbalanced assignment problem. So we have this Hungarian assignment technique for solving only balanced assignment problems only. So coming to the, if it is an unbalanced assignment problem, there is no any techniques for solving unbalanced assignment model problem. First, we need to convert this unbalanced assignment problem into balanced assignment problem. So here, I will explain here. Suppose if there are 3 persons, 4 jobs are there. Okay, 3 persons, 4 jobs are there. So if you assign one person to one job, there will be extra one job. So we have to convert this unbalanced assignment model problem into balanced assignment model problem by introducing one extra dummy person and put whose cost is strictly 0, 0, 0 like that. Okay, so 3 persons, 4 jobs are there. So I am converting this unbalanced. This is unbalanced assignment model problem. Now we have to convert this unbalanced assignment problem into balanced assignment model problem by introducing a dummy person. P4. Actually, we have 3 persons only, but I am introducing one more person P4 with whose cost is strictly 0, 0, 0. So that we can convert this unbalanced from unbalanced to balanced transportation problem. Once the problem can be shifted to balanced transportation problem, then go for the Hungarian assignment method. Okay. So for there is a method for solving only balanced transportation problems. If it is unbalanced, we have to convert it into balanced. Okay. I will explain the structure of this balanced and unbalanced on paper. Just say yes. Yes. Is it visible? Screen is visible? Yes. Here. Assignment model problems. Assignment model problems. So the structure of assignment model problem is here. Suppose I'm going to take 3 persons, P1, P2, P3, and here 3 jobs. J1, J2, I'm called with names J1 job, J2 job, J3 job. Okay. So, and this is some 1, 2, 3, 4, 5, 6, let us suppose whatever it may be, 7, 8, whatever it may be. And the meaning of this is here 1, 2, 3 means it is, if you see only first row. So this P1 person can be done this J1 job within 1 hour period of time. You can assume this is 1 hour or 1 day or 1 week or 1 month, whatever it may be. But it shows that this person P1 can be finished this job J1 within 1 hour period of time. This P1 person can be done this J2 job within 2 hours period of time. Similarly, what is the meaning of this? P1 person can be finished this J3 job within 3 hours period of time, like that. Similarly, 4, 5, 6. This 4 indicates second person can done this job 1 within 4 hours period of time. Similarly, what is the meaning of this 6? 6 shows that the person P2 can be finished J3 job within 6 hours period of time. Similarly, 7, 8, 9. If you take this 8, it shows that P3 person, third person can be done this J2 job within 8 hours period of, like that they given the values. And we have to take these values strictly non-negatives. Do not take negative quantities because we can't say, if I say this is -2, so P1 can take -2 hours or -3 hours, okay? Either it should be zeros or strictly positive. If you put 0, means P1 cannot assign to the, cannot done that job. It shows 0 time means 0 hours time means yes, within the 0 hours means P1 does not assign to J1 like that. If it is some time is mentioned within that stipulated time, we can say that person is going to done or finish that corresponding job. So here, if it is problem is like this, Now I want to assign which person to which job. Okay. So person to job. So P1 person. So yes, P1 is done, J1 job within 1 hour, J2 job 2 hours, J3 job 3 hours. Among this, which is the least time, by without taking any Hungarian method or any quantities, we can say directly, yes, within this is the least time. So this is the least time. So I'm going to assign P1 is assigned to J1. Once J1 job is assigned to one person, do not assign same job to remaining persons. Just strike out that. Okay, like this. Similarly, P2. Yes, remaining two jobs only we have to search. So P2. So P2 is done J2 job within 5 hours. This is 6 hours. J3 job is. So among this, which is the least? 5 is the least. Suppose this is 2. Let us suppose. Okay. P2 can finish J2 job 5 hours. P3 can finish J3 job within 2 hours. Then I can go for these 2 hours only. So P2 is assigned to J3 job like that. So J3 is also assigned to P2 person. And rest of job is only one. So obviously, defaultly, that job will be assigned to P3 person. So P3 is assigned to J2 job. This is the, like this, we have to take the assignment process. So, but what is final duration? Is J1 is done with J1, P1 is done with J1 job within 1 hour. Let's add all this. Plus P2 is done with J3, J2, J3 job within 2 hours. Similarly, P3 can be done assigned to J2 job and he will finish the work within 8 hours. So 1 plus 2 plus 8 means within 11 hours, this entire task will be finished. Like this, we have to take the assignment. So this is equal number of jobs equal to equal number of persons. So therefore, this is balanced assignment problem. If it is like this, let us suppose P1, P2, P3. Okay. But here I am going to take jobs J1, J2, J3, J4. I am going to take 4 jobs J1, J2, J3, J4. But actually, I have only 3 persons. This is, let us suppose 1, 2, 3, 4, 5, 7, 8, 1, 1, 2, 7, 8, whatever it may be. Let us take numbers. I don't want to discuss this again. So here persons are 3, but jobs are 4. Therefore, it is unbalanced. Unbalanced assignment problem. But these kind of model problems, we don't have any method for solving. So first we have to reduce this unbalanced problem into balanced problem. See here, how we are going to convert this unbalanced to balanced? Just which is less? Persons are less comparing the jobs. So we need to introduce one more dummy person. So just like this, I am adding the extra one row. I'm calling with P4, and this is cast strictly we have to put 0 means actually there is no P4 person. So no need to assign P4 to J1, P4 to J2, J3, J4. That's why I'm putting whose casts are strictly zeros. So like this, we have to convert this unbalanced to balanced. So here balanced assignment because 4 persons, 4 jobs. Once it is comes under the balanced, then go for the Hungarian assignment method like this visualization method or whatever it may be. So this is the first basic definitions on this. Okay, and see here coming to the first next mathematical formulation of this is important for short answer questions. Listen carefully. Mathematical formulation of assignment problem. AP assignment problem. That is, see here, if I say xij equal to some 1, it means if xij equal to, let us suppose, if I send that is value equal to 1, it shows that the ith person is assigned to jth job. The meaning of this one, xij equal to 1 means the ith person is going to assign exactly one jth job. The meaning of this. Suppose it is equal to 0. Let us suppose it means the ith person is not assigned to jth job. So 1 stands for assignment is done. 0 stands for the assignment is not done. Means the ith person does not assign to the jth job. So this structure is known as mathematical formulation of assignment problem. Okay. Similarly, if I say here, suppose here let us suppose if it is summation of xij equal to 1 and I equal to 1 to n. Let us suppose n persons, n jobs are there. The meaning of this is yes, the ith person is assigned to jth job. Okay. So here I am fixing j value constant and I am replacing I values, persons. I stands for rows. Rows means let us suppose this is persons and j equal to let us suppose this is columns and jobs. The meaning of this is so I am fixing j equal to fixed value and I am replacing I equal to 1 to n. So 1j, 2j, 3j. If you replace I values, it shows that the jth job is done by ith person. The meaning of this. Okay. Suppose if it is like this, summation j equal to 1 to n, xij equal to 1. It means yes, in this case, I am fixing the I values fixed and I am replacing J values. So J equal to 1, 2, 3, 4. It means xi1, xi2, xi3. It means the ith person, yes, previously I fixed J means job. Now here I am fixing I value. I indicates person. So ith person is assigned to jth job. The meaning of this. Okay. This is called mathematical formulation. Okay. I'll show you. In our textbook, we have all these theory part. Just go through this theory part. Okay. And next, coming to the next one. See here. Next. Coming to the applications of assignment model problems, where we are going to use these assignment model problems. It means here, I will give the one practical example here. In school level or in college level, whatever it may be, we are preparing timetable. Which class is first hour, which class is second hour, which class is like that. Okay, that is the best example of assignment model problems. Because in school level, we already seen that situations in school level. That is mathematics class. That is a very interesting class. You can put that is in the morning session. Okay. So mathematics class, we are going to keep that topic in the syllabus. That is in timetable. That is in the morning sections only. Okay. And languages, we can put in the afternoon session like that. Okay. So preparing the timetables is the best example of assignment model problem. Similarly, I'm going to discuss certain applications. We have to assign a right person to right job, or we have to assign a right contract to right bidders. Okay, right contractor to right bidders. We can assign a right client to right actions, or we can assign a right client to right sub-client, and we can assign right bidders or right tenders. In government sectors, we are going to make a tenders, so they will call upon the tenders. They will give the one figure. So different persons will come with their own action plan with the tenders. So and so overall cost like that. Government will see the which is the best and which is the least quality, least cost, so that you can select that so and so tender is the best, like that. So and preparing the right route to right vehicles. If certain areas, if traffic jams are there, Now I want to divert that vehicles to different routes so that we can avoid the traffics. So right route to right vehicles. So all this comes under the applications of assignment model problems. I will show it here. I will share the screen. See here. Is it screen is showing? Is the screen is visible? Yes, here. Actually, this is your context totally pure 18 units. So I started this 8th assignment and routing problems. So whatever the topics from unit 1 to unit 7, we already finished in a offline mode. Okay. I started from unit 8 remaining 16 minutes. Okay. Now today I started this assignment and routing problems. This is your syllabus complete 19 to 18 subtopics. Of course, you may receive the textbooks also next year. Just I will show the 1 minute. We'll share the screen. Okay, this is a general definition of assignment model problem and yes, this one. See here. So the applications of so assign salesperson to sales territories. So right salesperson to right sales territories. Next, assign vehicles to routes to avoid traffic jams. So right vehicle to right route. Next, assign accountants to client accountant. Yes, accountants to right client accountant. Next, assign contracts to bidders through the systematic evaluation of bids from completing suppliers. Next, assign naval whistles to petrol sectors. So right naval whistle to right petrol sectors. Next, 6th one. These are the few applications. Assign development engineers to several constructions of several construction sites. So it means to assign right engineer to right construction area. Next, schedule teachers to classes. Yes, this is the best example in we have to say we've seen in school levels. That is timetable, preparing the timetable. Schedule teachers to classes. Next, men to machine, men to matched machines according to pieces produced per hour by each individual on each machine, and teams are matched to projects by the expected cost of each team to accomplish each project. These are the few applications. Okay, if these questions came in your final exam, just write at least 4 to 5 applications. Okay, among these 9. Okay, these are the few applications. Next, coming to the next important topic already explained just now, that is mathematical formulation of assignment problem. Yes, mathematical formulation of assignment problem. In mathematically, the assignment problem can be stated as minimum z equal to, because I want to reduce the cost quantity. That's why I'm taking minimization cost. minimum z equal to or minimum z or total cost equal to z equal to or cost equal to summation I equal to 1 to n, that is n persons, and summation j equal to n jobs, n persons, n jobs with cost. Cij indicates cost and xij is the variable. Cij into xij for all I equal to 1 to n as well as j is also 1 to n. And coming to the subject to the constraints, here I am writing these assignment model problems so in LPP format. Objective function is minimum z is this. Double summation I equal to 1 to n, j equal to 1 to n, Cij into Xij for all I equal to 1, for all j equal to 1. And coming to the constraints, subject to the constraints, yes, just now I explained this. Yes, 1 stand for the ith person is assigned to jth job. 0 stand for the ith person does not assign to the jth job. Here, Xij equal to 1 if the ith person is assigned to the jth job. If it is equal to 0, it means that if the ith person is not assigned to the jth job. Okay. Similarly, summation j equal to 1 to n, xij equal to 1. It means here I am fixing the I value. I values I fixed it and I am replacing jobs j equal to. That's why the meaning of this summation j equal to 1 to n, xij equal to 1. It means that one job is done by the ith person. So any one of the job must be definitely done by the some ith person for all I equal to 1 to n. If it is like this, summation I equal to 1 to n, xij equal to 1, here I am fixing the job. I am replacing persons. So I equal to 1 to n, xij equal to 1. It means that only one person should be assigned to the jth job. Okay, the meaning of this. So here where xij denotes that jth job is to be assigned to the ith person. This is the mathematical formulation or mathematical structure of mathematical structure of assignment model problems. Okay, now let me discuss next methods for solving the assignment model problems. So I already told we have the only one method, that is Hungarian assignment method. It is scientist name. So whenever one assignment model problem is there, with the help of this Hungarian method, we can solve it. Okay, I will explain that complete method with one example. Okay, let us see. I will share the question. Let us take one example. With the example, I am going to discuss. One minute, I will share the screen. One minute. I'll share it. Here, let us take one example. With that example, I can explain. I'll explain complete the problem. Okay. Let us take first any one of the problem with a balanced. Okay. With the help of balanced assignment problem, then I will explain the how we are going to solve that balanced assignment problem with the help of Hungarian assignment method. It is scientist name. I will share this. Okay, see, this is the problem. So what is the problem? Just evaluate the problems here. here a department had, yes, read this, see the problem. A department had 4 subordinates and 4 tasks, means 4 persons, 4 jobs. Okay, this is purely application problem. Listen carefully. So a department has 4 subordinates and 4 tasks to perform the job. To be perform the job, the subordinates differ in efficiency and the tasks differ in their institute. I will, okay, wait. And differ in their institute difficulty. His estimate, that is the department head, his estimate of the time for each man would take to perform each task is given in the following table or in the following matrix. Means he given here different tasks, jobs, and here men, persons. So I'm giving the notations for jobs A, B, C, D, and men, persons, E, F, G, H. Okay, it means here 18, the first row 18, 26, 17, 11. It means the task A, job A, if I assign job A to person E, he can finish within 18 hours period of time. If I assign this A job to person F, then it can be done or it can be finished within 26 hours period of time. Like that, he given the different tasks and whose corresponding different man hours time. Okay, and what was asking, how should the task can be finished in total man hours? So we have to allocate the total task within what time we have to finish this entire task. So I will take this matrix form. Just listen. This is 18 Hungarian assignment method. Hungarian assignment here. What about first row? 18, 26, 17 and 11. 17 and 11. Second row 13, 28, 14, 26. Third row 38, 19, 18, 15, and last row 19, 26, 24, and 10. Okay, so just I will keep the numbers 18, 26, 17, 11, 13, 28, 14, 26, 38, 19, 18, 15, 19, 26, 24, 10. So here the tasks and here the jobs, or sorry, men. He is giving the notations A, B, C, D, and here E, F, G, H. See here. Okay. Let me discuss this problem. I will explain this problem on notes. Okay, see here. I will share the front camera. Right. This is the problem. Okay. Hungarian assignment method. It is scientist name. This is the only one method for solving assignment model problems. Means if I apply this method, it will give the right person to right job, so that we can finish the entire task within short period of time. This is the task. 4 tasks are given. This is the persons, men, 4 persons. Okay. Now we don't know which person is assigned to which job. If you visualize by saying, yes, A is done this, H person is done by this job within 11 hours time period of time. But obviously, D person also can be done this job within 10 hours period of time. So in this case, which job is assigned to which person, that will create a complication or confusion. For avoiding that situation, we have to assign this Hungarian assignment method. If you apply this method, definitely it will give right person to right job. See here. So it means here, whenever same job can be done the different persons within same period of time. Let us suppose in that situation, it will create a confusion. Which person is assigned to which job? So for that kind of situations, if you apply Hungarian assignment method, definitely it will give the right person to right job so that we can finish the entire task with short period of time. Okay. So now I will going to apply the how we are going to assign the right person to right job. In this year, first we have two basic steps. One is first step, row subtraction. I will explain the problem later. First listen. Row subtraction. Row subtraction means for the given matrix, we have to take the entire matrix as it is and see by only row wise. Here we have 4 rows. See in first row only, in first row, which is the least element. Select the least element and subtract the least element from the remaining elements in that only first row. That means by row wise, we have to select the least element and subtract that element to in that corresponding row only. Similarly, in second row, so number is least. Subtract that number to that second row only. Like that, we have to apply these condition for each and every individual rows. After finishing this row subtraction, next step 2, column subtraction. Apply the same principle by column wise. So see by column wise, which is the least element. Select that least element and subtract that least element from remaining all columns. Okay. First column, so its element is least. Subtract that element from only first column. Similarly, second column, so its element is least. Select that least element and subtract that element from only second row column elements. Let's say subtract that element from only second column. Like that, we have to finish this procedure till all rows and all columns. Okay, I will explain these problems here. Yes, is it paper is visible? Okay, I will explain the complete problem in paper. Here. So this is question. First, coming to the solution. First step, row subtraction. Row subtraction. Row subtraction means we have to choose. We have 4 rows and balanced assignment problem. Why? Because we have 4 persons, 4 jobs. Okay. Now, once if it is balanced, then go for the row subtraction. Next step to column subtraction, like that. Okay. First row subtraction. In first row, see which is the least element. 18, 26, 17, 11. So 11 is the least element. Now we have to select this least element 11 and subtract this 11 from only these remaining elements of this first row only, including this 11 also. Here, 18 minus 11, 7, 26 minus 11, 15, 17 minus 11, 6, and 11 minus 11. Obviously, one number will go to 0. That number minus that number only, 0. Next, in row wise, similarly apply this procedure for remaining rows also. 13, 18, 14, 26. So which is the least? 13 is the least. So select this 13 and subtract this 13 from remaining elements from this entire first, second row only. 13 minus 13, 0. 28 minus 13, this is 15. Okay. 14 minus 13, 1. 26 minus 13, 13. Next, in third row also, 15 is the least element. So select 15 and subtract from remaining elements. So 38 minus 15, this is 23. 19 minus 15, 4. 18 minus 15, 3. 15 minus 15, 0. Similarly, coming to the last row, 10 is the least element. So 19 minus 10, this is 9. 26 minus 10, 16. 24 minus 10, 14, and 10 minus 10, 0. So why I am doing this process means in each and every individual row, I want to get at least 1 0. Yes, in first row we got 0, second row we got 0, third and fourth row also I got 0. So apply same procedure. Yes, I will repeat once again here. Apply same procedure, that is subtraction procedure, by column wise also. This is A, B, C, D. This is E, F, G, H. Now we have to apply this procedure by column wise also. So here I am going to write column subtraction. Step 2. Column subtraction. Previous step I have taken row subtraction. Now we have to apply column subtraction here. So in first column, which is the list? 0 is the list. So if you subtract 0 from remaining elements, we will get same column. Okay. So 7, 0, 23, 9. 7, 0, 23, 9. In second row, second column, 4 is the list. If you subtract 4 from remaining elements from the second column, 15 minus 4, 11. 15 minus 4, 11. 4 minus 4, 0. 16 minus 4, 12. Next, in third column, yes, 1 is the list. Subtract this one from remaining elements. 6 minus 1, 5. 1 minus 1, 0. 3 minus 1, 2. 14 minus 1, 13. And in last column, we have 0 is the list. So if you subtract 0 from remaining elements, we will get the same column. 0, 13, 0, 0. Okay. This is about row subtraction and column subtraction. Now we can go for the assignment procedure. I will explain how we are going to take the assignment process. This is indicate this with the notations. Yes, it is A, B, C, D. This is E, F, G, H. And this is row wise. And one more thing, why we are going to take this assignment means in each and every individual row and individual column, there will be at least 1 0 must be present. That's why I am going to take this process. Okay, row subtraction, column subtractions here. In each row, we have at least 1 0, whether it may be 1 or more, but there will be 1 0 at least. 0. In second row, we have 2 zeros. In third row, 2 zeros. Fourth row, zeros. Similarly, if we take column wise also, because I applied column subtraction also. First column we have 0, second column we have 0, third column 0, fourth column also we have 0. Okay. Now, then we have to take the assignment process. That is, where 0 is there, in that corresponding box, put one rectangular box. Means that is assignment is done in that corresponding row. Okay, in row wise only, see where the zeros are there. Here we have 0. Only one single 0 is there. If it is more than 1 0, you can choose any one of them. But in this row, we have only one single row. I am selecting that one only. It shows that in that first row, the assignment process is completed. Once the zeros are assigned, it means person A is assigned to job H or job A is assigned to person H. Means these H job cannot be assigned to remaining persons B, C, D. That's why, see, is there any extra zeros by row wise or column wise? Simply we have to strike out them. In row wise there is no extra zeros. In column wise we have 2 zeros in fourth column. So strike out them. It means this H cannot be assigned to remaining persons because already it is assigned to A. Similarly, apply the same process to last row. Second row, we have 2 zeros. You can take this one or this one, the meaning is same. But I'm going to take the first row is first row. This is first column, this is third column with the priority by column wise. So first I'm going to assign this first. So it means E job is assigned to B person. Okay, or the task B is assigned to E person. So do not assign this E person to remaining jobs or this B task to remaining persons. So For that, that is the reason I'm striking out the extra zeros in row wise, in column wise corresponding to these box. So for this second row, assignment is done here, and see extra zeros by row wise. Here we have an extra zero. Strike out this, and extra zeros by column wise. There is no extra column zeros by column wise. Next, see third row. So third row, we have only one single zero. Already we have two zeros, but this zero is already cancelled. So just we have only one single zero. This is I am going to take assignment. So take extra zero wise row wise. Already this is cancelled. By column wise, there is no zeros. So it means this H job is assigned to A, F job is assigned to C, and E job is assigned to B. Now still we need to assign one more job to one more person. But in this year, we have to do this process. All each and every individual row, we have an assignment. But in fourth row here, there is no assignment because there is no extra zero. If it extra zero is there, then I can assign. But already we have one zero that is cancelled by assigning this A to H. So in fourth row, there is no assignment. So for these kind of model problems, we have to go to the next step. Now I want to start this Hungarian assignment procedure. After completing these two steps, row subtraction, column subtraction, now indicate the assignments. If each and every individual row assignment is done, then stop there only. That is the perfect solution. But here in third row, there is no assignment. Means in third row, assignment is not done. I'm sorry, in fourth row, assignment is not done means we have to go for the tick mark procedure. This is called tick mark. Tick mark procedure. I will explain how we are going to take the tick mark process here. So for this, we have to apply the principle this row, column, row. This is the only one important step in this entire Hungarian assignment method. Please listen carefully. So triple R, it is not triple R, RCR. Row, column, row. Row, column, row. It means in first row, take the tick mark where the assignment is not done. That is no assignment. So we have to take the tick mark by row wise where the assignment is not done. In first row, assignment is done. In second row, assignment is done. In third row also, assignment is done. But in fourth row, we don't have any assignment. So take that row as a tick mark. Okay, right? So no assignment, I am taking the row wise. So see in only fourth row, because assignment is not done in fourth row, in that corresponding row only, see columns. In which column? The zero as cancelled like this. Zero as cancelled. So see in this fourth row only, because we have already 4 rows, but I taken tick mark for fourth row only. That is assignment is not done. In that corresponding fourth row only, we have to see column wise. It means this is first column, this is second column, this is third column, this is fourth column. In column wise, where the zeros are cancelled. Here, zeros are cancelled. So here among this, zero is cancelled in which column? First, second, third, fourth column. So I am going to take this column as a tick mark. Okay. So next, see in this 1, 2, 3, 4 columns, I have taken the tick mark process in fourth column only. So see in only fourth column. Forget about remaining first column, second column, third column. See only fourth column. In fourth column, next in the corresponding column, coming to the row wise, where the assignment is done like this. Assignment is done like these symbols where we have by row wise. So see in this fourth column only, assignment is done here. That is comes under the which row? Is it first or second or third or fourth row? First row. Take tick mark on that row. Is it clear? So follow this principle. RCR. First row, no assignment. In that row only see column wise where zeros are cancelled. Yes, in this column. Next, in this column only, see where the assignment is made or assignment is done. Take that row as a tick mark. So in fourth column, here we have assignment. This is comes under the first row. So I am going to take this tick mark in that first row. Once the tick mark is completed, says, are you listening? Once the tick mark is completed, then go for the drawing straight lines. Drawing straight lines. I will explain how we are going to draw the straight lines. Draw the straight lines through unmarked rows, unmarked rows and marked columns. Marked columns. Use this principle for drawing the straight lines. So unmarked rows, marked columns. In this we have 4 rows. 1, 2, 3, 4. Unmarked row means where the tick mark is not present. So first and fourth row we have tick mark. Where the tick mark is not presented in second and third row. So take the straight lines in that row only. Second row, third row, I am taking the straight lines means it does not have tick mark. So that is the meaning of unmarked rows. And marked columns. We have to draw straight lines through marked columns. So we have 4 columns. 1, 2, 3, 4. Among these 4 columns, where the column it having tick mark, that is marked columns. So in fourth column only we have tick mark means I am going to take this like this. Okay, are you able to understand? So I will use another pen here. This is a red color pen. This is marked. This is unmarked rows. Okay, I taken that straight line here, and third row also unmarked rows. This is straight line, and draw unmarked rows and marked columns. Marked column means among 4 columns we have this is the only one marked column. So this is the straight line process. Once the straight line process is completed, yes, listen carefully. Once the straight line process is completed, then we have to take next step or we have to move the next step. Here from the elements we have to pick up next step. Next step number, assume this is step number 1. Step number 1, row subtraction. Step number 2, column subtraction. This is entire comes under step 2 or step 3, whatever it may be. This is step number 4. Step number 3, tick mark process, drawing the straight lines. Step number 4, and next step number 5. In step number 5, yes, I am taking least element. Least element. Select the least element from where the elements which are not passing through the straight lines. So in this, among all these 4 into 4, 16 elements, few of the elements are not passing through the straight lines. So we have to pick up the element, least element, which does not passing through the straight lines. So here, see how many elements are there which are not passing through the straight lines? 7, 11, 5. And here last one, 9, 12, 13. Among these 6 elements, which is the least? 5 is the least element. Like that, okay? Select least element 5, which is not passing through the straight lines. Okay. Once the least element is selected, next we have 3 sub steps or 3 sub cases. I will explain one by one. So once the least element is selected, and first step, subtract this least element 5 from the remaining elements which are not passing to the straight lines. So subtract this 5 from the remaining these elements which are not passing through the straight lines. So we have to subtract this 5 from 7, 11, 5, including 5 also, 9, 12 and 13. Okay, I'll do that. 1 minute. Here, what about next step? Select least element. Is it visualizing? So select least element that should be not passing through the straight lines, and first step, subtract that least element from the remaining elements. So next step, this is step number 6. So first I will draw the table entire table once again. So this is A, B, C, D. And this is E, F, G, H. So least element is here. Least element is 5. Now we have to subtract this 5, this 5 from the elements which are not passing through the straight lines. So here we have totally 6 elements, 7, 11, 5, 9, 12, 13. We have to subtract these 5 from remaining elements. So 7 minus 5, that one it is 2, 5 minus 11 minus 5. This is 6, 5 minus 5. So obviously it will goes to 0. And next, coming to the fourth row, 9 minus 5, 4, 12 minus 5, 7, 13 minus 5. This is 8. Okay. So this is the case 1. Subtract the least element 5 from the elements which are not passing through the straight lines. Next, add this least element, this element 5, to the intersection boxes. Means where the row straight lines, column straight lines are intersected. See here we have these two are the row-wise straight line. This is the only one column straight line. Means here these are the intersection boxes. This is intersection box, means straight lines of rows and columns are intersecting here. Here also straight lines of rows and columns are intersecting. Okay. So BH, CH, these two boxes are second row, fourth column, third row, fourth column boxes are intersecting. So for these two boxes, we have to add 5 to that corresponding number. Yes, I will write that elements here. Already it is 13. 13 plus. So we have to add this 5 to this 13. So this is 18. Next, it is 0. 5 plus 0 plus 5. It is 5. Okay. Next, last. So first I subtracted 5, the elements which are not passing the straight line. Next, then I added these 5, the elements which are intersecting the intersecting boxes. And next, write the remaining rest of elements, whatever the elements remaining we have, write that elements as it is, and write the remaining elements as it is. The remaining elements are as it is, means do not take any addition or do not take any subtraction. Write the remaining elements as it is. See how many elements we have after selecting this, subtracting, adding, the see remaining elements 0. Right, this is as it is. Next here 0 as it is. This 11 as it is. 0 as it is. Next 23 same 0. Next 2, and here we have one more element. This is 0. Okay. So once this step is over, then again go for the same whatever that step we did after column subtraction. Go for the assignment, like indicating the rectangular boxes. See here. So assignments. So each and every individual row, just see the zeros are there. In that zeros, we have to take the assignments here. Coming to the assignment indications. So in first row, we have 2 zeros. Okay. You can assign this 0 or this 0. The meaning is same. But if you take instead of this, if I choose this 0, assume if I choose this 0, so A is assigned to H, A is assigned to H. But in this corresponding, we have to, after taking the assignment, we have to cancel the corresponding zeros by row wise, column wise, means these 0 cancelled and these 0 cancelled. So again, there is a problem in the fourth row, because we in fourth row we have only one single 0. If you assign this one, this 0 will be vanishes. So Again, we cannot get the assignment in fourth row. So we have to assign that kind of situations before going to take the assignment. Okay. So instead of this assign 0, I will choose this 0. Okay. So choose this one. So I am assigning G person to task A. Okay. Now, once the assignment is done, see is there any extra zeros by row wise or column wise. By row wise, we have one extra zero. Strike out this, cancel this. And by column wise, we have one zero here. Okay, I am canceling this. Next, even though this zero is cancelled, in second row we have one more zero. Okay, no problem. Next, in second row, yes, how many zeros? Two zeros, but already one zero is assigned. So I'm going to take assignment for this zero. Okay, see, is there any extra zeros by row wise, column wise? After taking the assignment, yes, assignment is over. Extra zeros by row wise, we have one zero, but already it is cancelled. Column wise, there is no zeros. See here. Next, coming to the third row. In third row, how many zeros we have? Only we have one single zero here. So I'll go to take assignment here. And is there an extra zeros by row wise? No. Extra zeros by column wise? No. Yes. Coming to the next. In fourth row, how many zeros? We have one single zero. So I'm going to assign this zero. And is there any extra zeros by row wise? No. By column wise? Yes, we have one zero, but already it is cancelled. So like this, we have to finish the assignment and again go check the condition. In each row, one assignment is done or not. Yes, in first row, assignment is completed. Second row, assignment is completed. Third row, yes, we have assignment. In fourth row, yes, it is assignment is done. It means the assignment is existing in each and every individual row. It means the optimal solution is exist or we got the final answer or the optimal solution is obtained. Therefore, stop here only. Suppose after applying this tick mark process, drawing the straight lines and selecting the list element, all this process, again assignment is not done in any one of the row, then go for the again tick mark process, straight line process, everything we have to apply all these steps one more time. But what I'm saying, once the Hungarian tick mark process is completed, maximum situation we can get the assignment in each and every individual row. Okay, so what is final assignment? Therefore, optimal assignment. Therefore, the solution is exist. Solution assignment is exist. Assignment is exist, and the optimal assignment is yes. A person A is assigned to which one? A is assigned to G. See where the assignment is over done in that corresponding row. A is assigned to G. Next B is assigned to E. Yes. Are you following me? A is assigned to G, B is assigned to E, and C is assigning to F, and D is assigning to H. So this is yes, each and every person is assigned to each one task. Okay, but I want to write this time duration. Now go for the original question. What is our original question? This is our original question. See here. Okay. Now coming to the original question again. A is assigned to G. A is assigned to G means how much time he is taking? Yes, 17 hours. So this is 17 plus. Next, B is assigned to E. B is assigned to E means 13 hours. So plus 13. Next, C is assigned to C here. C is assigned to F. C is assigned to F means what is corresponding time schedule? 19 hours. So this is 19 plus. And next, D is assigned to H. This is 10. Okay, this is final answer. So add all this 17 plus 13. This is 30 plus 40 plus 40 plus 19, 59 hours. Totally 59 hours. Within a 59 hours period of time, the entire 4 tasks can be assigned to 4 men or 4 persons, so that he can finish this entire task within the least time is 15 hours. So we can't done these 4 jobs to 4 tasks not less than to this 59 hours. Okay, this is the least time only. within the 59 hours only, we can finish this entire 4 tasks by these 4 persons. So this is the least time for this problem. Okay, is it clear? Like this, we have to done, or we have to assign the right person to right job. So see, in this entire matrix, I will, after getting the answer, we have to check out the verification part. See here, I will explain the one steps here. Once the problem is completed, we have to check out whether he got correct answer or not by taking verification. Okay. In this here, so I got here A is assigned to G, and B is assigned to E, C is assigned to F, and D is assigned to H. But I want to know whether this assignment is correct or not. So like this here, see in that entire matrix, which is the least number. If it is some 2 is the least number, let us suppose, definitely that 2 is assigned to at least compulsory 1% that assigned to 2 number. If it is 2 is not done in that assignment process, then your entire problem is incorrect. See, I will check out this here. So in this here, in this entire matrix here, 18, 26, 17, 11, see, elements. 18, 26, 17, 11, 13, 28, 14, 26, 38, 19, 18, 15, 19, 26, 24, 10. Means in this entire matrix, 10 is the least element. Yes, is it clear? 10 is the least element. Definitely, these 10 must be assigned to any one of the person to any one of the tasks. That comes under the or solution part. Here, 10 is here. Okay, like that. You can check out whether you got the correct answer or not. Okay? So this means 10 means this D is assigned to task D is assigned to H person because he is finishing within short period of time. This is the total duration, 59 hours. Within 59 hours, we can finish these 4 tasks by 4 persons. Okay, is it clear? This is the assignment model problems. Right. Next here. So next we have one more problem, that is, so all these problems comes under the minimization assignment model problems. So in this problem, I am not asking any question, just solve the problem by Hungarian assignment method. Solve the following assignment model problem by Hungarian assignment method. If anything is not asked, defaultly the question will goes to minimization assignment model problem. If it is, we have some more example, some more problems like maximization assignment model problems. It means in the question itself, they will mention that word. So assign the right person to right job so that we can get the maximum profits. If it is problem is related to profit, in that situation, everyone will assign the profit, will take the profits must be maximizations. So in that situation, I want to assign, I want to get the maximum amount or maximum cost or maximum time, whatever it may be. So the problem which is related to profit case, in this situation, the problem will go to maximization problem. So the problem solving the maximization assignment problem, we don't have any methods. Simply, if the problem, let us suppose the question is solve the following assignment model problem so as to maximize total cost. Is it clear? If the question is like this, solve the following assignment model problem by Hungarian assignment method so that we can take the maximum profit or maximum cost. If the problem is like this, we don't have any methods for solving these type of model problems. Just the only one step is to reduce that maximization problem into minimization problem. Once the problem is comes under the minimization problem, then go for the same row subtraction, column subtraction, that is Hungarian assignment method process. But coming to the how to convert the maximization assignment problem into minimization assignment model problem. So here, if the problem is belongs to maximization assignment problem, first see in that entire matrix, see which is the maximum number or which is the maximum element. If it is previous problem, see here, I will show it. In previous problems here, if this problem is like this, if I say this is maximization problem, in this entire matrix, which is the maximum number, 38. 38 is the maximum number. So select the maximum number 38 and subtract the remaining all elements from 38. I will repeat once again here. Here the maximum number is 38. So select 38 and subtract remaining elements 18, 26 like that up to 10. Remaining all elements including 38 also. Subtract remaining all elements from 38 and write the corresponding numbers here. So that if you do this step, so selecting the maximum number from the entire matrix and subtract remaining all elements from that maximum number, so that the maximization assignment problem comes under the minimization problem. Okay, like that we have to shift the maximization problem to minimization problem. Once the problem comes under the minimization problem, then apply same previous Hungarian assignment method technique only. So I will repeat once again here. In what way we are going to convert the maximization assignment model problem into minimization assignment model problem? See that entire matrix, which is the least element. See that entire matrix, which is the maximum cost. Select that maximum cost element and subtract the remaining all elements from this maximum number. Like 28 and 38 is maximum. 38 minus 28, it is 10. Not 28 minus 38. If you do like this, we can get the negative numbers. Okay. So select the remaining all elements from this maximum number, so that the entire matrix comes under the minimization matrix problem or minimization assignment problem. Once the problem comes under the minimization assignment model problem, then go for the same steps. Do tick mark process, row subtraction, column subtraction, tick mark process. If the assignment is not an each and every individual row, do the tick mark process, straight line process, everything, and go for the final again assignment. And once the assignment is done, select the which person is assigned to which job, and from the original matrix, that is maximization matrix, we have to pick up we have to write the corresponding total cost that indicates the final answer. But in this also, how we are going to take the verification part? Definitely, in that entire, after completing all the assignment, if 38 is maximum number, let us suppose, definitely that 38 number must be assigned to compulsory any one of the person. That 38 must be involved in the solution part. Okay, like that we have to do the maximization assignment model problem. Okay, I'll show it one problem here. Yes, I'll take extra 5 minutes. See here. If same, this is problem is the, let us suppose same is the problem is, let us suppose if I say this is, yes, what is our problem? Let us take same this problem 18 here. If I say this is the same problem 18, 26, 17, or else you can take one of maybe I will take the general problems here. I'm going to convert the maximization problem to minimization problem. See here. Suppose maximization problem. In the question itself, they will ask the maximization assignment problem. If anything is not given, do every time minimization problem only. If especially they asked for that kind of questions only, we have to convert this maximization assignment problem. Let us suppose this is 2, 5, 7, 8, 12, 14, 3, 5, some 7. If it is problem like this, A, B, C, D, E, F. Okay, this is persons, this is jobs. Let us suppose now I have 3 persons, 3 jobs. My question is maximize the total cost. They will give you the question like this: maximize the total cost. Means first we have to convert this maximization problem into minimization problem. Minimization problem by selecting maximum number and subtract that number from remaining elements. We have to subtract that element from remaining all elements. So 2, 5, 7, 8, 12, 14, 3, 3, 5, 7. Which is the least element here? Oh, sorry, which is the maximum number here among these 9 elements? 14 is the maximum number. Maximum number is 14. Now we have to subtract remaining all elements from this 14, so that the problem can be shifted to minimization problem. This is A, B, C. This is D, E, F. See here. Now 14 is the maximum. So subtract 14, 2 from this 14. 14 minus 2, this is 12. 14 minus 5, 9. 14 minus 7, 7. 14 minus 8, 6. 14 minus 12, 2. 14 minus 4, 14 minus 14. Definitely one of the element will go to 0. Next, 14 minus 3, 11. 14 minus 5, 9. 14 minus 7, 7. So automatically this problem can be shifted to minimization problem. So I'm converting this maximization problem into minimization problem. Once the problem shifted into minimization problem, I can go for the same steps. Is do this row subtraction, column subtraction. If assignment is not done, take the tick mark process and the straight line process. From that, we have to pick up the least element and subtract the least element from the elements which are not passing to the straight lines. Add that least element to intersection numbers and write remaining elements as is. Do all this process again. Go for the finally assignment. Let us suppose the final matrix. If I got like this, let us suppose after doing all these steps, I got the matrix like this. I'll show it. This is A, B, C. This is D, E, F. Let us suppose here 0 and here 1, 2 something, here 0 and this is, let us suppose 0, this is 4 and here 0, 7, 6, let us suppose like this. I got the matrix like this, okay? After taking the tick marks, everything, yes, first A is assigned to D, next B is assigned to F, and this is C is assigned to E. This is the assignment process, okay? In each and every individual row, we have one assignment. Therefore, the optimal assignment is A is assigned to D, B is assigned to F, C is assigned to E, okay? And what is its time duration? So A is assigned to D. So this is maximization, this is we converted minimization. For our convenient, we converted to for our convenient, we converted problem into from maximization to minimization. So finally, don't see this matrix. We have to select these elements from original matrix. A is assigned to D, means this is 2. So see the original question. Do not select the number from these minimization problem, because for our convenient only we subtracted this maximum to minimization. Okay. So this is our original question. So we have to choose the values from our original question. So A is assigned to D. Next, B is assigned to EF. This is 14. 14 plus. Next, plus C is assigned to E. C is assigned to E means 5. So this is answer. So 19, 19 plus 1, 21 hours. So this is the final answer. And we have to check out whether it is correct answer or not by selecting this here. In this entire matrix, which is the maximum number? 14. So that is definitely assigned here. B is assigned to F. B is assigned to F means 14 is here. So this is 14. That 14 will present in the final optimal assignment. Next, C is assigned to F means E means this is. So this is final assignment. So like this, we have to take the assignment process, whether it may be minimization problem or maximization problem. Okay. Okay. With this, as here, as almost it is a 6:05. Okay. With this, I will going to stop the class because this time is up. Tomorrow we will continue the next class. Okay. So please go through the whatever the topics we discussed today. Okay. Okay. Let us stop. Stop. We'll stop the class. Let us continue in next class. Okay, let us continue next class.